My name's Andy Wilkinson. I work for Pivotal, where I'm the lead of the Spring IO platform and also a committer on Spring Boot. I'm going to be talking today about documenting RESTful APIs and kind of talking about some of my experiences gained from when the Spring projects were part of VMware. I worked on a very large RESTful service for managing and provisioning middleware, and part of that, the challenge in implementing that was obviously documenting the APIs, and that's where a lot of the thinking that I'll cover today came from. So I think when you're about to embark on documenting a RESTful API, one of the first things to think about is exactly how RESTful your API is, and the reason why that's important will become clear in a moment. So a gentleman called Leonard Richardson back in 2008 coined the concept of the REST maturity model, which describes kind of the evolution of an API towards being truly RESTful. And some people, if you take a purist view of REST, there aren't really degrees of RESTfulness. You have to be in this model. You have to be at level 3 to be able to call your API RESTful. But I think there's some room for maneuver there. I don't see it as quite as black and white as that. There are shades of grey involved. And so you need to look at your API. A level 0 API. Hopefully none of you are there and calling your APIs RESTful. That's really, at level 0, it's an XML-RPC kind of SOAP-style API where you just have a single endpoint that you're operating against. And the description of everything that you're doing and what you're doing it against is all in the body of the request. If you move up to the next level, rather than everything being described in the request body and there just being a single resource that you're talking to, you have separate resources involved. So you have multiple URIs that you're now calling, but you're calling them all in the same way. The next level, up to level 2, you start to introduce the use of HTTP verbs. So rather than kind of trying to describe the actions in the body of the request, you start making use of HTTP GET, PUT, POST, PATCH, DELETE, etc. To describe the action that you're performing. So the resource is what you're performing it against, and the verb is the action that you're performing. And then the third step is kind of, now you're in the purest sense, you are now RESTful, where you've introduced hypermedia into your API. So you now have links in your responses that tell people, from a particular resource, what other resources can they navigate to. And this brings some benefits to your API in terms of how robust it is and how easy it is to refactor the API. If you're using hypermedia, you can make changes to your URI structure as long as your clients are following links in the responses. They won't be broken by those changes because the API is described in terms of links and their relations rather than the actual URIs themselves. And this is important because the different tools that you can use to document RESTful API vary depending on what level you're at in the maturity model. There are some tools that will cover you, for level 2 and level 3. Some tools will stop at level 2 and won't help you document a level 3 API, and some are only appropriate for a level 3. If it's a full-on hypermedia API, some tools are only appropriate for that sort of approach. So it's something to bear in mind when you're thinking about your API and how to document it. You should also think about, in terms of, you can place your API in the REST maturity model in a particular level based on how it is today. It's also worth thinking about how RESTful you'd like it to be. If you have aspirations for your level 2 API to become a level 3 API and introduce the use of hypermedia, you might want to bear that in mind when you're considering what approach to take with documenting the API, so that your documentation approach doesn't become a kind of inhibitor to making that move up to the next level in the maturity model. Another thing to think about when you're considering your API and how to document it is things that you can do in the design of your API to make the documentation process easier. There are design decisions that you can make that will make your life documenting the API much more straightforward. So one of the things that you can do is to be consistent in your use of HTTP status codes, for example. So the HTTP standard defines a whole raft of status codes that have very well understood, almost universally adopted meanings. It's well understood that an HTTP 200 response means okay, the request worked. A 404 means that the thing that you were talking to wasn't there. 400 means that it was a bad request, etc., etc. In your API, you should make, you should take full advantage of that. Wherever you're using status codes, you should use them consistently because it means you don't need to document them. It's a fairly reasonable assumption that anyone using your API will be familiar with HTTP and its status codes. If they're not, then you don't need to document those. You can just point them to all of the existing literature on HTTP status codes and their accepted meanings. The same goes for HTTP verbs. Use them consistently. Always use, if you're accessing a resource in a safe manner, always use get. If you're creating a resource, you would use post. If you're deleting a resource, you'd use the HTTP delete verb. One area with the verbs that's also worth thinking about is you may want to make a decision about how you treat put and patch requests. There arguably is a bit of a gray area in the HTTP spec there, where it's not clear which of put and patch should be used to do a complete replacement of a resource and which should be used when you're just making a partial update. So it's worth making a decision, which do you want to use, how you want to use them, and doing so consistently across your whole API. Means you only need to document it once, and it also means that your users get a much better experience because once they've learned what you're doing, they only need to learn it once, and they don't need to wonder if I'm talking to this resource, is it going to behave this way versus if I'm talking to that resource, is it going to behave in a different way? Another thing to consider in your API, if you're using hypermedia, then I think it's really important that you make the relations on your links unique. So here's an example. This is a response formatted using hypermedia application language, HAL for short, with a couple of links in it, a notes link and a tags link. And those are the relations of the link, and they're a key part of the API. It would be reasonable for a client to look for a link with the notes relation or a link with the tags relation. And it's really important that anywhere in your API that has a link with, say, the notes relation on it, that the thing that you're linking to is always the same type of resource. That means then that whenever a client sees a link with a notes relation, that they know if they access that link, what sort of resource, as a result, they're going to be dealing with. And they don't need to worry about where they were coming from. They don't need to think, oh, well, this response that I got back was from this particular resource. So that means a link with the notes relation is going to be to this type of resource, whereas if they'd accessed something else, the notes link is going somewhere else. If you use those relations consistently and always link to the same type of resource for a link with a particular relation, it gives you less to document, and it also, again, means that your clients can make, and your users can make, learn something once, and then just make a safe assumption that applies across the whole of your API. So now I'd like to talk a little bit about things that I think you should document in your API. These are the kind of the things that I consider to be the most important things to cover in the documentation of a RESTful API. The things that you should put front and center in your documentation. I think the most important thing that you need to do to talk about in your API documentation are the resources that are involved in your API. This is really important because this gives the mapping. So a user who's coming to your API, I think it's a safe assumption, safe to assume that they will be familiar with the problem domain that your API is tackling. For example, there's a Stripe or a payment processor, and they have a very nice, very well documented API. And their documentation talks about all of the sorts of things that you'd expect to find when you're thinking about the problem domain of payment processing. It talks about credit cards and expiry dates and billing addresses and transactions and refunds, all those sorts of things. So when you come to their documentation, you immediately feel at home, and kind of because you're surrounded by concepts that you're already familiar with. The same goes for GitHub's API documentation that we'll look at a little bit later. Their documentation talks about all of the sorts of things that you'd expect to find in the in the GitHub problem domain. So it deals with repositories and issues and commits and pull requests. And all of those things are kind of, they're the primary way in which the documentation is subdivided. So it's very easy to apply your existing knowledge of GitHub's problem domain to the to the documentation of their API. It's equally important, once you've described the resources, it's equally important to talk about the input that they accept and the output that they produce. So this is talking about, what should a request body look like? What can I expect a response body to look like? If you've defined a custom media type for your API, this is the sort of thing that you want to describe. You should talk about your media type, or perhaps you're just using plain application JSON responses, or perhaps you've decided to use JSON but formatted using the HAL standard that I mentioned earlier. It's the sort of thing that is important to document up front. And also, if you've taken on board the goal to being consistent as possible, something that you only really need to document once. If you're using HAL across the board, you can just mention that once up front, describe the general structure of a HAL formatted response. And that information applies across all of the resources, so there's no need to kind of repeatedly mention it elsewhere in the documentation. It's kind of building on top of if you're using HAL, you also need to document for each resource what links you can expect to find. So if I access this resource, where am I going to be able to go? What link should I expect to receive in a response? And equally importantly, what's going to be at the end of that link? If I access that link, what sort of resource am I going to start dealing with? This kind of comes back to my point earlier on about the consistency and the uniqueness of your link relations. It's very easy if you've used relations consistently and also uniquely, so that a rel of a particular type always goes to a resource of a particular type. It makes documenting your links pretty easy and pretty straightforward, and also means that your clients are given a consistent kind of predictable API to work with. I think it's also very important to document any cross-cutting concerns that apply to the API. And you should take an opportunity to document all of these once. These are things that apply across your whole API. There's no need to mention them multiple times. You can just mention them once up front, and then people can kind of apply that knowledge to all of the different resources in your API. I talked earlier on already a bit about HTTP status codes and HTTP verbs. So, for example, if your cross-cutting says you might want to document your interpretation of put versus patch and the approach you've taken there. It's worth talking about authentication and authorization. How, if at all, do people authenticate with your API? Do you use, for example, is everything just done over SSL and you're using basic authentication? Or is there something, are you using, API keys or something like that? Are the concept of different roles in your API, do people need to have, does authorization come into it and they need to be authorized in a particular role to perform a certain operation? The general concepts of those sorts of things, the different roles in the API, are all worth documenting up front. You may be using rate limiting in your API, so you might want to describe exactly how the user is supposed to know about the rate limit. For example, you might be using HTTP headers to tell them how many requests they have left available in the current rate limiting window when the window resets, for example. All these sorts of things that should apply generally across the whole of your API. You can document them once up front and then just let people apply that knowledge to all the different resources. So that's a bit about the sorts of things that I think you should document. But equally important, I think there are things that you should avoid documenting. And the primary thing that I think you should really avoid documenting is URIs. Now, this is, it may sound a little bit extreme to not document URIs at all, but I really don't believe that you should, the URI should be kind of even a primary or even a secondary kind of level piece in your documentation. There are two main reasons for that. The first reason is, I talked earlier on about the resources in your API being something that's very important to document, and them providing a familiarity for the user with the problem domain. So if they're already, they're coming to it with a familiarity with the problem domain and what's going on, seeing all the resources, and talking about using GitHub again as an example, if you talk about your resource for working with issues, they're already familiar with things. But if you put URIs as kind of a primary kind of level of the documentation, the URI won't mean much to them, because it's just they might be able to look at it and break up the individual parts of it and figure out that this URI has got something to do with issues. But you're asking them to do more work to find the bit of documentation that they're looking for. It's much better if you lead with the resource concept that fits the problem domain that they're already familiar with, to really help them find what they're looking for in the documentation as quickly as possible. The second part, second reason why I don't think documenting URIs is a good idea is that if you've taken a hypermedia-based approach and yet you document the URIs too prominently, and I say this from bitter experience, people will just ignore all of the links that you've included in your responses and will start hard coding the URIs instead and start trying to create them themselves. And before you know it, you thought that you had a level 3, your API was at level 3 on the REST maturity model, and all of the clients are using it like a level 2 service. So all of the benefits that you gained from using hypermedia and the robustness of the API and the fact that you could change the URIs, and as long as the links were all still remained, it wouldn't cause a problem, all of that goes out the window, and you'll change URIs and you'll start breaking clients. And if you're lucky, you might be able to get away with that, and you'll just be able to say, well, that's the client's problem. They need to fix it. But in some situations, the people on the client side team, they'll say, well, we didn't change anything, and it just started breaking, so it must be the server side team's fault. And you may get told to put the service back the way it was. So I think you really need to kind of, if you've gone for a level 3 based approach, you don't want to undo all your good hard work by then encouraging people to write clients in the wrong way. And so one thing you can do to help with that is avoid making the URIs too prominent a piece of your documentation. So now I'd like to talk a bit about, to kind of put some of that theory into practice and show you a little bit, first of all, what it looks like when you get it wrong. And this is really learning from my mistakes. So I'm going to show you the documentation that we produced for the RESTful service that I mentioned earlier that was for provisioning and configuring middleware. So this was for a product that was, it could provision various bits of middleware, some of which you may have heard of, you may be familiar with. Gemfire, RabbitMQ, for example, TC Server, which is was a commercial kind of Tomcat offering. So for those of you familiar with Tomcat, which I assume is the vast majority of you, there are some concepts in Tomcat that you'd expect to see in the API documentation. You can start and stop a Tomcat instance. It has configuration files. You can deploy web applications to it, and things like that. If you look at this API documentation, none of those things are immediately apparent. You could look at this documentation, and if I hadn't described what the service did, you'd probably be all at sea and you wouldn't know. It would take you a long time to figure out what the service was for. Whereas if you've got, kind of nicely formatted documentation and that's focusing on the resources, it can become apparent quite quickly from looking at the documentation what the service does. So I think that's the first thing that we got wrong here, is that we've documented the URIs far too prominently. The things that the different URIs do is described, but the URIs are very much they're in the biggest text, and they're in the center and they catch your eye. Another thing that we got wrong, if I open up the documentation for a particular resource, you can see that for every single resource, we've documented that an HTTP 200 is what you'll get back in the event of a successful request. And that's just standard HTTP semantics. If a GET request is successful, you'd expect to get a 200 response. We've also documented that a 404 means that something didn't exist, and a 500 means that a server-side error occurred. It's all correct, but it's not. It doesn't differ from resource to resource. So in terms of the information about this specific resource, that information is really just noise and something that a reader of the documentation they have to parse it and kind of, oh yeah, I don't care about that, and ignore it. So you're not giving the readers of your documentation a very good experience by describing that kind of common stuff on every single resource. It's much better just talked about once, leaning on the existing HTTP standards and things, talk about it once up front, and then you just don't need to mention it again for the rest of the documentation. And you can focus on what is interesting for that specific resource in the individual resources documentation. There are a few things that I think we did right in this documentation. One thing that we spent a lot of time on was making sure that we included example requests and responses. And this is something that I would encourage you to look to do in your API documentation. I think it really helps people when they're trying to write a client against the documentation, seeing examples of what a request should look like and what a response should look like can really help them figure out bugs if they've got something wrong in the client or they've misunderstood what the server is supposed to be doing. So that I think we got right, but I think the key thing to take away from this documentation is that while pretty much all of the information that you might want to see is in the documentation, the structure and the way that we subdivided that information with hindsight was wrong. And going for a resource-centric approach would have given users a much better experience. So on a more positive note, I'd now like to talk about what it looks like when you get it right. And to do that, I'd like to show you GitHub's API documentation. So one of the really nice things, before we start talking about this documentation, one of the really nice things is that GitHub's API documentation and the tooling that they use to produce it is all available on GitHub. So you can go there and you can have a look at this and kind of learn from what they've done. And there's some interesting things in there. It's all written in Markdown, for example, which is a good format for writing documentation. So if you're curious, you can kind of dig into this and see what they've done and how they did it, and maybe learn a bit about how you could apply that to your own documentation. So the first thing that I really like about GitHub's API documentation is that they've got this really nice overview section up front, which describes all of the things that I've been talking about, that kind of those cross-cutting concerns across your API, that if you use things consistently, you only need to talk about them once. So, for example, they've documented their use of HTTP verbs, and they've described here how they've interpreted put and patch. And they've also described that, they've said patch is relatively new and uncommon. So they also allow you to use post to make a partial update for a resource. And that applies across every resource in the API that you can make a change to. So they've used that consistently, and now they only need to document it once up front. And they've got similar stuff in there for, some of the other things I talked about. Authentication, their use of hypermedia, how they treat pagination, their approach to rate limiting, for example. They're using HTTP headers to describe what the limit is for a particular resource, how many requests are remaining, when the rate limit window will end. And these are things that apply across, and now any resource that is rate limited doesn't need to document any of this. You just need to denote this resource is rate limited, and these are the header. Go to read this bit of the documentation if you're not familiar, to find to find more information out about the rate limiting, the headers and things that are involved to find out about it. So it's really nicely done approach of covering all of the cross-cutting stuff up front in the documentation. Another thing that they've done in the documentation is then they've then broken everything down by the parts of by the resources. So, for example, we're now looking at the documentation for working with issues. So here we've got, so you immediately feel at home. You're immediately familiar with the concept of issues on GitHub. And then they subdivided this by, listing issues, listing a repository's issues, dealing with a single issue, et cetera, et cetera. And note that there's no URIs here. They're still kind of leaning on your familiarity. And, you would come to the documentation, all right, I'm using the REST API. I wonder how I create an issue with it. You're not then trying to figure out which URI you should be looking at. It's right there, right in front of you. It's kind of the primary way that they subdivided the information. So it's very quick and easy to get into the bit of documentation that you care about. And then on each individual resource, so they have documented the URI, but you're really into the meat of the documentation before the URI appears there. And then they've got really nice examples of, look, this is what a request body should look like. In this case, we're creating an issue, and then this is the sort of response that you should get back. So this is the response body. This is what you should expect. There's a bunch of fields in there you'll expect to see. Example rate limiting headers. They're using an HTTP 201 response here, which is basically, you asked me to create this thing, and this is where it is, and the location header is used to provide the link to where the newly created resource exists. So I think the key thing to take away from the GitHub documentation is really two key things, I think. One is the way that they've subdivided the information. They focused on the resources, and URIs are kind of barely mentioned. And then they've also, again, they've got these really nice example requests and responses so that when you're working with the service, or writing a client, it's very quick and easy to see. You know what to expect when you're dealing with the API. So having talked a bit about what I consider to be good and not so good API documentation, I'd now like to talk a little bit about some of the various tools that are available that you can use to document your API and help people to familiarize themselves with it. The first tool I'd like to talk about is Swagger. This is probably, I think, if you did a straw poll of developers and mentioned documenting a RESTful API, I suspect Swagger would be perhaps even by far and away the most common answer. It's certainly, I've seen it come up a lot. A lot of people do seem to be using it, which, as I'll go on to explain, I have some reservations about. So Swagger is there's two pieces to Swagger. In one part, it's a specification that describes a metadata format, which is then used to display documentation to describe your API, and that's how the documentation is produced. And then another piece of it is there are various projects that integrate with server-side technologies to produce that metadata. And in the concept of the Spring universe, there is Swagger integration for working with Spring MVC. There are also, on the JVM, there are also, for example, integration for working with JAX-RS, for example. And what those integrations do is they look at your implementation's code. So in the case of Spring MVC, it's looking at your controllers and all of your methods annotated with request mapping and figuring out what input those methods take and what output they will produce. And then it takes all of that and generates the metadata that is then displayed in the documentation in a browser. And there are some downsides to that approach that we'll cover in a minute. So one of the problems with Swagger is that it doesn't have any support for hypermedia. So if your responses have links in them, Swagger can't really help you there. There was an issue raised against the core Swagger specification in early 2013, and after about 18 months of discussion, they decided to close it in the middle of 2014 as not per their design. which is fair enough. So they've made a statement that they don't think that Swagger should be used to document a level 3 on the maturity model API. And that's fine. It's just something to be aware of when you're picking a tool to use, that if your API is a level 3 API or you have aspirations to get there, Swagger may not be the right tool for the job. Another problem with Swagger, and this is generally applicable, is that it's URI centric. So no matter where you are on the REST maturity model, if you're level 2 or level 3, for the reasons I explained earlier, I don't think documenting the URIs kind of front and center is the right approach, because it just doesn't give people that familiarity with the API. So here, this is the classic, it seems to come up a lot, classic pet store application. And so they've broken it down a little bit. So these are all the operations that deal with pets. So we know that we're dealing with pets here, but then immediately we're now looking at URIs. And if you contrast that to the GitHub documentation, where we were looking at issues, but then rather than listing all the different URIs that deal with issues, they were then, they'd listed, in terms of what you might be trying to do. So you might be trying to create an issue or update an issue or list all of the repository's issues. And they were still talking it was in natural language what you were trying to do, rather than putting a URI in front of you with then a kind of a description of what it does off to the side that gave you a bit more work to do to figure out exactly what you should be doing and how to do it. One of the other things with Swagger is that it doesn't give you anywhere to document all of those cross-cutting concerns I talked about. The documentation for the RESTful service that I showed you earlier was very heavily inspired by Swagger. We were, at the time when we were producing that documentation, we were quite enamored with Swagger. We didn't use it largely because of the hypermedia limitation, and we needed, our RESTful API was hypermedia based. But we did take a lot of inspiration from Swagger in terms of the structure of the documentation, and I think that was to the documentation's detriment because, for example, in Swagger, there's nowhere for you to document your consistent usage of HTTP verbs or any of those cross-cutting concerns, the status codes, any rate limiting you might have, etc., etc. They end up appearing in the documentation for every single resource, so you're contributing a lot of noise to the documentation that your users then have to wade through. So I talked a little bit earlier about Swagger's approach for looking at your your JAX-RS endpoints or your Spring MVC controllers and trying to interpret those methods and what they're doing, the input that they accept and the output they produce, and generate metadata from them. And unfortunately, Swagger sometimes gets it wrong. And now this was a bug, arguably, in the Swagger Spring MVC integration, and it may have been fixed by now. I don't know. I first found this problem at the back end of last year. But even if this specific problem has been fixed, I think it kind of illustrates a broader problem with the approach. That if you're that using your services implementation to produce the documentation opens you up to a whole class of problems that you'd be better off avoiding. For the tool to work properly and produce the correct metadata, it has to have an intimate and entirely, exactly correct understanding of how the back-end system works. And in a modern, JAX-RS or Spring MVC framework, there are lots of pieces involved in there are an awful lot of moving parts between some HTTP being received and a method invocation on your controller happening, and also on the way back out on the response, the return value from that method goes through potentially a series of steps before it gets turned actually into the HTTP, the response that's sent back on the wire to the client. You might be using Jackson with some custom serializers or deserializers. You might be using an exception mapper in JAX-RS, or maybe a controller advice in Spring MVC. For example, say you've got some controller advice that maps a legal argument exception to an HTTP 400 response. If the framework that you're working with doesn't understand all of those different pieces, it's not going to be able to accurately produce the correct metadata that describes what your API produces and what it consumes. And this example here illustrates that. We've got, so in Spring MVC, there is a type called a response entity, and it encapsulates the status code that's going to be included in the HTTP response, any headers that you want to add to the response, and also the body of the response. But what's happened here is that's been misinterpreted, and this is basically saying that the body of the response is going to include a status code, some headers, and a body. And it knows, the status code is an enumeration, so it's going to have one of, and there's every single possible HTTP status code, is going to appear in the body, which is just obviously wrong. It's just a concrete example of a problem that can occur if you use a system that is trying to infer from your implementation exactly how things are going to look when they're turned into HTTP requests and HTTP responses. And I don't think it can be avoided. I think it's a risk that you accept if you use a framework that takes that approach. Another thing to be aware of with Swagger is that it's a fairly hefty dependency to add to your application. So I wrote a sample app that used Spring Boot, Tomcat, and Hibernate to produce a RESTful API. And the archive for that application weighed in at 25 megabytes. So this was a Spring Boot kind of executable jar. So it's got Tomcat embedded in the app. It's the kind of the bring your own container approach. I then added Swagger to it, and that added 31 megabytes. So my 25 megabyte app was now a 56 megabyte app with more than 50% of its weight being contributed by the tool that was just documenting the API. It wasn't adding anything functionally. It was just there purely for the documentation. This may not be a huge problem for you. It really depends on, what deployment model you're using. But, if you're taking a continuous delivery approach, or perhaps you've got hundreds of instances of this RESTful service, those additional 31 megabytes, if you're doing tens of deployments a day to hundreds of machines, they very quickly add up, both in terms of the deployment time and the network bandwidth that you're going to use. So again, it's just something to be aware of. If you decide to use Swagger, these are all things to be aware of, that you're making trade-offs and accepting some compromises. The second tool that I'd like to talk to you about is something called HAL Browser, which builds on top of the hypermedia application language response format that I talked about earlier. So what the HAL specification does is it describes the exact format that a JSON response will take. And what the HAL Browser does is it builds on top of that. And because it knows exactly what form the responses will take for an API, because they're in this well-known HAL format, so it knows where to look for links and things in the hypermedia-based API, it can provide, essentially for free, some basic kind of documentation and navigation support for your API. And I'll show you that now. So this is the HAL browser that's just pointed at the root of a RESTful service for note taking. So the two main kind of resources in this are notes and tags. And you can create a note which has some text in it, and then you can add tags to the note to kind of categorize all the different notes that you've created. And because the RESTful service is using HAL, and the responses are in a well-known format, it's able to pull some information out of the response and present it to you in a browser to allow you to kind of look around and navigate and get a feel for the API. So you can see, for example, in this response, there are some links, and there's a notes link, and there's a tags link. in the response, and it's smart enough, because they're in this well-known HAL format, it's smart enough to pull them out of the response and offer them to you in the browser so that you can perform a GET request against one of the links. And it also offers some documentation. Now, this documentation is provided via this curries link. So you include in your application some static HTML files which document a particular resource. And using a templated URI, so you're saying here resource docs, and then you put the rel of the link into the URI, and that will allow you to access the documentation. And the browser makes that available to you. HAL browser makes that available. So this is just very rudimentary, just for the purposes of example, is the description for this particular resource. And you can put whatever you like in there. It's just HTML, so anything that you can write in HTML can appear in that documentation. So it makes it available via the HAL browser, but also has the advantage that it's available to anyone, any client that is using your API can look at this, and this is a benefit of the HAL standard. Any client that's looking at your API, the documentation for a particular resource is just a link away, and those links are provided to them in the response body. So it's very easy as a developer using the API. If the API is using HAL and has these nice documentation links, you can very quickly access it, which can be really useful and can make it a lot easier for someone to familiarize themselves with your service. And yeah, you can follow links. So here, I followed that link, and I'm now looking at the notes resource. There aren't any notes in the service at the moment, so it's kind of a dead end as things stand. It also has support for executing non-GET requests, so you can perform things like post or put. So you can use this to create a new note, for example, in the service. One downside of HAL Browser, I said earlier on, we looked at the notes resource, and there's nothing there. It's not telling me there's no links, there's no response body for it to look at, because the response was empty. There are no notes in the service. If there were any, perhaps I'd get a list of them back, but I don't know, I can't tell. And that's a disadvantage of HAL Browser's approach of, it hasn't collected or generated any extra metadata. It's purely built on the fact that the responses are in this well-known HAL format. But if something doesn't exist, it can't provide any documentation for it. So there is a downside to it. So I don't think dropping HAL Browser in, I don't think you can just do that and call it done. But you do get quite a nice amount, including this kind of interactive tool for working with the API, essentially for free. There's nothing that you need to do. You don't need to change anything on the server side, and it's a very lightweight addition to your application, as it's just an HTML page and a little bit of JavaScript to provide the browser. I'd now like to talk to you about a new alternative to documenting RESTful APIs that I've been working on that's kind of built on my experience of documenting the middleware provisioning service, and then also looking at and using other services' API documentation. And in working on this, I had three main goals. So one goal was to write as much of the documentation as possible in a format that's designed for writing. One thing that I dislike about Swagger and also the documentation that we did for the middleware provisioning service was that because we were trying to use the implementation to provide the documentation, whenever we wanted to add any descriptive text to go in the documentation, we ended up using annotations in the implementation to provide that descriptive text. And annotations are a terrible way, and using your IDE and annotating are a terrible way to write documentation. You're just not in a good environment for writing good documentation. And I think as a result, the documentation suffered because the writing's not of as high a standard as you might like it to be. So a goal was to follow, inspired by what GitHub have done. They use Markdown. So I wanted to use a format that was really good for writing documentation. So if you're trying to write descriptive text, I wanted to be that to be in a familiar format that was designed for the job. Another thing I wanted to avoid was using the implementation to provide the documentation for the reasons that I described earlier, that it's very hard to produce accurate documentation if you're using the implementation to do it, because you need to be aware of all of the moving parts, custom exception handling, custom serialization, deserialization of payloads, etc., to produce accurate documentation. So I wanted to kind of take a step back and document things at the level of HTTP requests and responses. I wanted the documentation to be dealing with the things that clients would be interacting with, rather than something that was kind of a step removed from that, as it is if you try to use the actual implementation to provide the documentation. And thirdly, I also wanted to be able to provide some guarantees that the documentation was accurate. I wanted it to be difficult, ideally impossible, but if not, then difficult for the documentation to get out of sync with the service. One problem with an approach like Swagger, a kind of a workaround that they have for perhaps not being able to understand all the exception mapping and things that might happen, is that you can add a Swagger-specific annotation to a controller method that lists, for example, all of the HTTP status codes that it will return. And while that can make your documentation correct at that point in time, it can very easily get out of sync, because if someone changes the exception mapping, perhaps they add a new mapping, so there's a new status code, they also have to remember, now I need to go and change the Swagger-specific annotation to mark that status code could be returned. So you end up repeating yourself. You end up declaring the kind of the exception mapping, the status codes that can be returned in two places. And that brings with it all the typical risks when you're repeating yourself, that things can get out of sync and your documentation can quickly become inaccurate. So that left me with something that uses ASCII Doctor. If you're not familiar with ASCII Doctor, it's kind of a markdown-like syntax for writing documentation, and has there's a whole ecosystem built up around it. So there are lots of great tools and things that you can take advantage of. It uses Spring MVC test, so that provides some of the assurances that the documentation is accurate, because we're actually testing. We're running tests as part of producing the documentation, and you can drive it pretty easily using Maven or Gradle. Integrate it as part of the build process. So it's something that's produced at build time, and then you can host the documentation wherever you like. It's not something that gets added into your application and kind of sits around at runtime. So this is an example of what a test method that is both testing and documenting a particular part of the API might look like. So just to walk you through the steps that are involved here. This is using Spring MVC test. So in step one, I'm performing a GET request against /. So I'm accessing the index of the service here. And I'm asserting that I'm going to get an HTTP 200 response back in step two. And then in steps 3 and 4, I'm asserting that there are going to be some links in the response. So I'm expecting a links with a notes relation and a link with a tags relation. And I'm using JSON path to identify those links. If you're not familiar with JSON path, but you are familiar with XPath, then it's basically JSON path is to JSON what XPath is to XML. So it's a means of very easily kind of identifying pieces of a JSON document. And then in the fifth step, I'm documenting the request that we've just tested, and the index example text in there, that's just telling the documentation framework where to write out the snippet of documentation that this test will produce. And what it does is it will produce 3 snippets for you. It will produce one that describes how to make the request using curl. It will produce a second snippet which shows you the response that you got back, and then a third snippet which is both the request and response combined. So to show you an example here is the snippet that it will have generated for the response to that request. So we can see that I got a 200 OK back, we can see what the content type was, and we can also see the links in the response, the tags and the notes relations on those links that we'd asserted would be there in the test. What I can then do in an ASCII doctor document is import that snippet and include it in the documentation. So here you can see, for example, here's an example response for a particular resource in the API. And one of the really nice benefits of making use of ASCII doctor is that I can take advantage of all the other pieces in the ASCII doctor ecosystem. So here, for example, I'm making use of ASCII doctor's support for syntax highlighting. In the snippet, I've identified that this code block contains HTTP. It's HTTP format data that's going to appear in there. And the syntax highlighter that ASCII doctor uses is then smart enough to color code the response based on the fact that it knows HTTP. And I believe it even goes a step further in that it's looked at the content type header and seen that it's application JSON, and is then smart enough to format the JSON response appropriately, the right highlighting around keys and values, etc. So a really nice kind of benefit of using a tool like ASCII doctor. You get to take advantage of all of the ecosystem all around ASCII doctor and all these existing little features and tools that it has to offer. Taking things a little bit a step further, we might want to document some links when we're documenting a particular resource. So here again, in step one, I'm making a GET request against the index of the service, and I'm saying I expect to get an OK response back. And I'm saying, yep, and I want to document and write some snippets to index-example again. So that will produce the 3 snippets that I described earlier. But then taking things a step further, I'm also asking it to produce some documentation about the links. So I'm saying that I expect to find a link with a notes rel and a link with a tags rel, and providing some descriptive text for those links. And what's happening here is the Spring RESTdocs framework is smart enough to look at the content type of the response that you get back and see that it is HAL. So it then knows how to pull out, how to extract links from a HAL response. So it knows how to find the notes link, and it knows how to find the tags link. And there's a pluggable abstraction in there. So if you're not using HAL but you are using Hypermedia, you can plug in an implementation of the link extractor interface to extract links as appropriate for your response format. And what that will do, that will produce a 4th snippet that describes those links. So I've asserted in the test that I will find a notes link and a tags link, and it's produced a snippet that documents those along with the description. And also what happens is if the response includes a link that you haven't documented, the test will fail. And if one of the ones that you expected to be there isn't there, the test will also fail. So you have a guarantee that the links that you've documented are the links that the service is producing for this particular request. And again, you can pull this into ASCII doctor, import it in an ASCII doctor document, and you get all the nice formatting, links to the resources, etc., for all of the documentation. So that's the Spring kind of a whistle-stop tour of the Spring RESTdocs documentation. I would love it if you would try it out. I'd love to get your feedback on it. It's not a fully fledged Spring project yet. It may become one. It's kind of still in incubation at the moment. It's available on GitHub. So please do take a look. And as I said, I would love to hear your feedback. I'll just take a moment now, just quickly show you an example of some documentation that was produced using Spring RESTdocs and ASCII doctor, and it kind of hopefully will reinforce some of the points about the structure of the documentation I was talking about. So there's, in the documentation, this was all just written in ASCII doctor. So, it's a tool that's very well suited to writing the documentation. and have covered all of the, the cross-cutting concerns up front in the documentation. But then further on, we can dip down into the individual resources, and you can see, right, I'm talking about the index of the service, and it's now talking about what sorts of things you can expect to find in the documentation. So here, for example, here's an example response, and this was produced by a test that we've just looked at. The links, the same links table, produced via a test and just imported into the documentation. And it takes the same approach for all of the resources that are relevant to this particular service. So, thank you very much, everybody. As I said, I would love to hear your feedback, both on the Spring RESTdocs presentation project and on everything I've talked about today as well. You can find me on Twitter or on GitHub, or that's my email address as well. So yeah, as I said, I would love to hear from you. Please do take a look at Spring RESTdocs and let me know if it's useful. What it does well and what it's doing not so well. Thank you.
Excellent. Andy, thank you so much. Can you hear me?
I can.
Okay, great. Just checking. So, wow. Yeah, almost 300 people at one point. We've still got a lot of people on the line, over 170 people. So let's get into the Q&A. Let's see. First question comes from Keith Hoops. He says, the usefulness of REST API's documentation, assuming you use HAL plus JSON, can possibly be dependent on how well it's constructed. Can you give a brief overview of the guidelines you like to follow when building a well-constructed, organized RESTful API? I feel like you somewhat addressed that throughout the course of this entire webinar, but if there's something pithy you feel like you want to say, go for it.
I think my main piece of advice when you're trying to write a RESTful API is structure it in a way that will feel as familiar as possible to someone who's already familiar with the problem domain. So using the GitHub example, for example, if like a GitHub repository has issues associated with it, and people know that an individual repository have issues. So make it very easy to navigate from the repository resource to the issues resource. And I think that's the main thing to do. Make things in your API, make the structure of it as familiar as possible to someone who's already understands the domain that your service exists in, and that will go a long way to making your API easy to use.
Cool. Ben Zhang asks about automatic tools to generate API documentation. I think we kind of covered that, talking about Swagger, but he asked that at about 20 minutes after the hour. So I don't think you were yet talking about your tool at that point. So I feel like we kind of covered that in talking about Swagger, but
yeah,
is there anything else you want to add? Okay. All right, great.
No, don't think so.
Okay, cool. Let's see. Oh yeah. Keith Hoops goes on to ask, could you give a code documentation or code sample or documentation example of what you should do instead of documenting a URI? And that was asked at about 10:30, 10:25.
I think I hopefully illustrated that when I was talking, for example, about the GitHub documentation, where you should lead with the resources. And if your API is only at level 2 on the maturity model, you will have to talk about URIs, but I would kind of push them down below the fold, if you like, and lead with resources first, and only tell people about the URIs when they really need to know them. And if you're using a hypermedia API, I'd make as little mention of URIs as possible, and talk about you should document resources and links and the relations on the links, and leave URIs largely for just example requests and responses.
Got it. Okay. Excellent. Thank you. And then Keith he had a couple questions right at the beginning. He was the first one to raise his hand, so that's why I'm just reading multiples from him. But this is a good one, actually, really good one. He says, some of his fellow engineers, colleagues have expressed concerns about transmitting secure requests over a GET when that request requires transmission of sensitive data. So how can I transmit sensitive data and still remain RESTful? It's a great question.
I would. It depends what piece of security you're in. I mean, on the wire, then use SSL and hope the NSA aren't listening. And then beyond that, there's nothing to prevent you requiring someone to have authenticated before they can perform a GET request. So you can obviously limit the access to a particular resource based on the credentials that have been provided via whatever mechanism you're choosing, so that you, if you use SSL and only allow a properly authenticated and authorized user to access a resource, then I don't see any problem with sending sensitive data in response to a GET request. Yep.
Okay. Yeah, I was tempted to think SSL too, but I wasn't sure if there was more to it. Interesting. Okay, so let's see. So we already talked about generating API tools. Okay, we already talked about that. Yep. And then next up, we had a question from. Actually, it's more of a comment. Miguel Quintero says, "Hey, what about apiary.io? Have you ever heard of apiary? API-ARY?
Yeah, the API blueprint stuff.
Oh, is that what that is? Oh, okay, that's the API blueprint. Oh, okay, cool, because you talked about that in the last session too.
Yeah. So for those who aren't familiar, they provide it's like a superset of Markdown that allows you to write a specification for your API. So you before you've written any code, you write this specification document in this superset of Markdown, which is quite nice because Markdown, is a nice tool for writing API documentation. And then for some platforms, I believe it can either spit out a skeleton back-end implementation. I'm not sure there's anything that runs on the JVM, but I think it can generate, a Node, for example, back-end, or maybe even Ruby on Rails, something like that. So yeah, it's a different approach, and it does tackle the API documentation. It's quite interesting. I personally am not a fan of writing that kind of specification document to describe my API because it reminds me too much of WSDL. But you may not have that aversion to WSDL that I do. So yeah, it's worth a look. It's certainly an interesting approach.
Cool. Excellent. Yeah. So you see that pretty complimentary. That's what you were saying in the last one. Julio, who has a long hyphenated last name that I won't attempt to reproduce here, he makes kind of a funny comment. He says, "Hey, wait a minute!" At about 10:50 a.m., so that was pretty recently. He says, "Hey, wait, isn't this HAL browser considered a simple REST client?" But that was kind of funny. Good point. Yeah, so he was just curious about your HAL browser, and he's like, "Well, wait, isn't that a simple REST client?"
Yeah, it is, and it's showing you, the HAL browser has no knowledge of the specifics of the API, but it shows you the benefits of using a consistent format in your responses because you can produce something that does have some utility, and that works purely because you're using a well-known response format.
Yep. Cool. Okay. There's a request for the GitHub address for the tool that you were talking about. Would you leave that up on the slides so that people can go check it out?
That one.
Cool. Okay. And he found it. I just wanted you to post it for everyone else as well. John Considine asks, what is your opinion of RAML, R-A-M-L? How heavy is the tool? He was saying he went on to comment. You mentioned that Swagger is kind of heavy. So how heavy as ASCII Doctor, for example?
So RAML's more like a kind of an API blueprint approach where you write a typical approach is you would write a spec document in RAML that describes your API. So I don't particularly like it for some of the same reasons that I'm not massively keen on the API blueprint stuff. In terms of how heavyweight is ASCII Doctor, in the examples that I showed, it doesn't matter because the big difference, so the typical approach when you use Swagger is to include Swagger in your application and serve the documentation generated by Swagger as part of your app. So you add that additional 31 megabytes to your application. The approach that Spring RESTdocs takes is that all the API documentation and the use of ASCII Doctor happens offline. It happens as part of the build process and then spits out static HTML pages that you can host anywhere you like. So ASCII Doctor itself is quite heavyweight, but that doesn't matter in this particular case, or I don't think it does, because it doesn't add anything to your application. It's just part of your build tool chain, and once it's done its thing, it doesn't have any. ASCII Doctor doesn't bloat your artifact that you've built. It's just involved in the process of producing the documentation.
Cool. Okay. Let's see. Mitch asks, how does your documentation philosophy gracefully coexist with REST service versioning without just poo-pooing the whole concept of REST service versioning?
So I guess he's talking about in terms of evolving an API, adding links, changing links, moving things, how you make those changes. There's nothing specifically built into Spring RESTdocs to cope with that. But equally, there's nothing in it to stop you, from documenting that. And it largely depends on the approach. There are lots of different approaches that you can take to versioning a RESTful API, and I'm not sure there's any kind of consensus on what the right approach to take is. Some people just do myservice.com/v1 and then myservice.com/v2, and don't attempt to offer any versioning. It's basically two just completely separate services. That's what GitHub did. They have moved to the V3 of their API, and I think V2 may still be running, or they may have switched it off now. But they didn't really make any attempt to kind of migrate a service. They just stood up a completely separate service with completely new documentation. So that's one approach. Another approach, you can kind of try and evolve your media type and add attributes to it, and maybe deprecate other ones. There's nothing specifically in Spring RESTdocs yet to help with that, but I'd be interested in, if people have that use case and they're trying to evolve a media type and adding, optional attributes to responses or things, and they're interested in how to document them, then I'd love to hear from people. So if someone does have that requirement, then drop me an email or open an issue on GitHub describing what you're trying to do, and we'll see what we can come up with.
Awesome. Cool. Keith Hoops was curious, did you explain how ASCII Doctor is getting info from the tests?
So that's really via the snippet. So there's the document call that you can see here that's happening on step 2 is plugs into Spring MVC test, and then it basically gives it access to the request that's being sent and the response that's coming back, and writes out the snippet file that I showed. So, for example, there's a snippet. So it writes that snippet file out onto disk in a well-known location, and then in your ASCII Doctor file, which contains the bulk of the verbose kind of descriptive stuff about your API, you can then import the snippet files from the well-known location and pull them into the big document, the main document, and it just renders them all in line.
Awesome. Okay. Wow. Bunch more questions coming in here. Whoa. Yeah. Bunch more questions coming in. All right. I'm going to try to pick up some speed so that we can get through this quickly. There's still 112 people on the line, down from 200. So clearly a lot of folks interested in the Q&A. Let's see. Let's try to keep this to be like a yes/no. Can you package the docs as a PDF with your tool, or not? Not at this time.
Yes, you can produce docs in any format that ASCII Doctor supports, and one of those is you can produce PDF documents.
Cool. Kind of a comment from Mike B. He says, sounds like a lot of work to use the tool, but good docs usually are. This goes well with the rel profile API. I'm not familiar with that, but looks like an ITEF, one of the RFCs. Any thoughts on that? I don't know if you're familiar with that. RFC 6906, rel profile API?
Not off the top of my head.
Yeah. No. Mike, sounds like you might want to just ping Andy on that offline. Andy, I'll get you the URL that he mentioned in the chat at some point later, so you can check it out and you guys can have a conversation about it over Twitter or what have you. Let's see. Mike Bracewell asks, is the request mapping info you showed in your documentation also generated from the @test annotation code, or is it only in the response body?
So I'm guessing he's talking about the hrefs for the links. No, they're coming from, that's the actual response that's coming back from the service. So that's exactly what the service is producing. So there's nothing clever happening to figure out what those URIs are going to be. That's just what appeared in the response.
Got it. Okay. Let's see. Okay. Sean Casey asks, would the Spring REST doc approach with a JAX-RS based app? Wait. Sorry. Hold on. Let me rephrase it. Sorry, I read that wrong. Would the Spring REST doc approach, your project approach, with a JAX-RS based app, or does it work with JAX-RS based apps, or is it only Spring MVC for the moment?
So it works with anything that can sit behind Spring MVC's dispatcher servlet. It's something of it somewhat overly narrows the scope to talk about it being a tool for documenting RESTful APIs. You can document anything any service that you've implemented and sits behind Spring MVC's dispatcher server, and that, I believe, includes some of the JAX-RS implementations. For example, I believe you can configure REST-easy to work in a Spring environment and kind of sit behind the dispatcher servlet in Spring MVC test. So yeah, you could. Certainly, my understanding is that you could use this to document an API that was implemented using JAX-RS. Very
cool. Let's see. Okay. Question is, how is put different from post in an update operation? It's kind of a general REST question there, but.
Yeah, so I often forget these off the top of my head. So there's a distinction between, so the main distinction is between doing a partial update to a resource. So there's creation of a resource, which is typically post, and then there's the difference between a partial update to a resource and kind of a wholesale replacement of a resource. So, and I'll probably get these the wrong way around off the top of my head. I believe that patch is often used just purely for a partial update to a resource. So, for example, if you send a request just with a single attribute, it just simply replaces that one attribute on the resource. Whereas if you did that with a put request, you're basically saying, I want to make a wholesale change. So if I've only sent a single attribute, I want you to remove all the other attributes and just leave it with the one that I've sent in the request body, which may or may not be a legal thing to do. That may be an invalid request. But that's where the key difference comes down to. It's the difference between doing a creation and doing a partial update and a wholesale replacement of a resource.
Very cool. Okay, we're almost out of time, but I think we're almost out of questions. And believe it or not, we're managing to make it through most of the question crew, which I think is pretty amazing here. a bit of actually, you know what? Hold on. Let me pause on that one for a second. This is a bit of he's got a bit of a off-topic one. Moataz asks, how do you send or document a bulk delete? Let's say if I have 100 items delete, should I consider HTTP post or HTTP delete?
So you want to. So one option that you might want to do is you might want to have a collection resource that kind of represents all of some things in a system, and you might want to consider, allowing the entire collection to be deleted. So you could make a single delete request and delete the whole shooting match. It's difficult to offer specific advice without knowing the exact requirement. I certainly wouldn't. Using a post to delete resources does not feel very RESTful to me. So without knowing any of the specifics, I would advise against doing that. I personally, out of preference, I would send 100 delete requests rather than abusing post to do 100 deletes. But it's difficult to say without knowing the exact situation.
Well, like I was saying in the last session, this is where a lot of the art comes in, right? With Rust, is like figuring out how to sort of map the semantics of what you're trying to do to the existing language of HTTP verbs and status codes. Cool. Okay, so then Mike B asks, perhaps a bit of an aside. Andy, you talked about HAL. Any thoughts on on that versus JSONAPI.org by Yehuda Katz and Steve Klabnik?
No, not really. I'm not particularly familiar with it, so I don't have any. Certainly don't have any real world experience of using it. So I no thoughts really on that versus HAL.
Got it. Okay. Well, if anything, I think you've gotten a fair number of inspirations, right, from some other community people popping up about this and that project. It seems like an active space.
It really is.
Yeah. Let's see. Almost at the end here, Andy. Lewis Moss asks, is there a way to get the full API docs in a JSON file?
So not at the moment. The way Spring REST docs is implemented, the intention always was the fact that it's writing stuff out into ASCII doctor snippets was always intended that it could become pluggable if needed. I had thoughts that some people might prefer Markdown versus ASCII doctor. There would be nothing stopping you plugging in something else that wrote it out to JSON or whatever format you liked. Someone was wondering about perhaps you could use it to produce something that was in the API blueprint format, which would be another option. So no, you can't do it at the moment. But it's always been in the back of my mind to make the actual output format pluggable, and this would be another use case that might motivate that piece of work.
Yep. Okay, I think we're going to call it at this point because it's almost 30 minutes after. The last question here, again from the same guy from before, Lewis, who asked about the JSON. He says Swagger has the benefit of interacting with the API. Any thoughts of adding this ability to your tool? I feel like you kind of covered that through the sort of main thrust of your whole presentation here, but do you have any brief words you want to say on that as a conclusion?
Yeah, very brief. No, I don't have any plans to add that. The documentation that's produced is designed to be kind of offline, static HTML, so that kind of integration isn't really appropriate for this approach. And also, I question the benefits of that kind of interactive playground as I think it's just a substitute for having poor documentation, and I would rather that people spent the time to write good documentation rather than leaning on the playground, which I think it just really teaches people how to drive your API in a web browser, not actually how to use the API from a client that they're writing in Java or Ruby or JavaScript or whatever. So I think it looks good in a demo, but beyond that, I question its utility.
Yep, absolutely. Yep. Cool. Well, then, I learned something today. Thank you. Yeah, I feel like I could have answered that question myself after listening to you. So thank you very much for that, Andy. And I just want to make people aware, please come back and join us on February 17th. We're going to be launching Spring XD. So if you're interested at all in big data, Hadoop, stuff like, Kafka, Spark, stream processing, machine learning, those types of things, you should definitely join us for that. That's on February 17th. I'm about to put the registration link into the chat window right now. That's for that one. And then join us again on the 24th of February. As we will be talking, Josh Long is going to be introducing Rob Winch's new project, a Spring Session. So if you've ever had to deal with, in-memory session replication, or been sort of back in the classic app server days, this is a real interesting technology that you might want to take a look at, especially if you're thinking about sort of moving from the old app server world and moving towards more sort of 12-factor, cloud design pattern, microservice design patterns. This is definitely something I think you might want to take a look at. With that, man, Andy, thank you so much. This is great. Really appreciate your time, all the energy you put into this presentation, and I think that's it. There's no Maven downloads in this one, so this is just going to your GitHub repo. Please try it out. If you liked the presentation today, maybe do Andy a favor by giving him some feedback and helping him make the tool better for all of us here in Springdom and beyond. I think with that, thanks for everyone's time. And Andy, you want to say anything before we call it a wrap?
Just reiterate your thanks. I hope everyone's found the presentation useful. And please do give me your feedback on email, Twitter, GitHub issues, whatever. I'll take your feedback any way I can get it.
Awesome. Andy, thanks so much. Have a great day. Bye-bye, everybody.